Good morning, everybody. How are we doing this morning?
Amazing.
Oh, wonderful. Great weather for ducks. Welcome to the other room. This is going to be nominally a laboratory session, but as we really don't have much to do in the way of laboratory exercises today, and I didn't quite get through the lecture material from yesterday, it is my intention to bore you all with the final piece of yesterday's lecture material, at which point we're going to spend probably 5 or 6 minutes doing Lab 0, after which the rest of the period is free, and you may leave. So, without further ado, I'm recording today. I forgot to forget my charging cable. So, let's get back here. Where did we leave off? I'll go back a few slides as well, as I feel the last few were a little bit rushed. See, whenever you're getting used to somebody else's slides for the first time, it's like you're never quite sure what their intended pace is, you know? Like, personally, because I'm a bit of a talker, my slide pace is like 12 to 15 slides an hour-ish. That's kind of, my comfort zone. This is a slide deck containing 51 slides, so even if the front matter is mostly, skipped because we talked about it separately, let's just say I'm still getting a little used to the material. I appreciate your patience, and I will try not to have this, I'll try not to make a habit of this spilling lecture material over into the lab session. This is about where we were. So let's pick it up from select queries. So, but of course, let's recap a couple of things. Let's recap a couple of things before we get there. Number one, this is a course on SQL, Structured Query Language. We are going to be dealing with relational databases reasonably extensively. You know, that plant wall thing actually produces a fair amount of noise, right? You know how much quieter it is with the door closed? It's interesting. Anyway, more than you would think. You would typically think of plants as being quiet, but anyway. So, SQL, absolutely. SQL is a language where you enter queries one at a time or in groups, and those queries specify operations over the database, right? So the hello world of SQL queries is the select statement. You may remember yesterday I talked about CRUD operations, C-R-U-D. What was C?
Create.
Create, good. What was R? Read. That's right, U? Update. And D?
Destroy.
Destroy. See, there we go. So, our, to some extent, it's kind of putting the cart before the horse, to read before you have written anything, right? Because, at this point, it's not like you could create a database from scratch, right? So in that sense, we're not really doing, anyway, this is the most basic query I can show you, though, but it presumes you have an existing database, right? So what the select query does is it pulls out of the database items according to what table you're looking for. And there are lots of other clauses we can tack on here too as well to make it more specific. You know what? Since we're in a computer lab this time, why don't we just kind of mix the Lab Zero stuff in with this stuff so that it's a more effective lesson and you guys can actually try stuff. Does that sound like fun? Okay, very good. So the SQL engine we will be using in this classroom is Microsoft SQL Server Express. Question?
Do you want us to download this on our personal or use the desktop so you
if you have sufficient access to lab computers to be able to complete your assignments, in general the labs are designed that you should be able to accomplish them within the lab period, then you should not require this installed on your own computer. However, for the purpose of individual studying, for the tests or stuff like that, I do recommend at least trying to install this on your own computer. However, computers vary greatly from computer to computer, and basically if you're Mac or Linux are on your own, and if you're certain types of Windows, you're also on your own. Linux people, I at least have some confidence that, saying you're on your own, they'll be able to handle that, but because they're left on their own so much. But that's okay. So, for standard Mohawk computer, lab computer setups, the software that we want is in Mohawk Apps. So, if everybody could please at this time load up Mohawk Apps and log in. Come on. Very good. Unfortunately, the version of the program which is currently installed is pre-pandemic. You can't even download this version anymore for your own home installation. So, but it still works. It still works, and there's only trivial differences between this version and all subsequent versions. So, I don't know if I would update this or just get rid of it entirely and move to Docker. But that's, those are future plans. You have a question?
I just definitely think this is probably pre-pandemic because Kira 4.3 is on here and Kira is on 10 now. So.
Yes. It's a constant battle. It's a constant battle. I'd love to talk to you about it after class. You had a question?
Oh yeah, I did. Do we have to install apps anywhere?
No, on your own computer, you will be able to get SQL Express from the Microsoft website. I believe it's 2022 is the least recent version that you can get. So yeah, you'll need not only SQL Express but also the database management system. Instructions on how to do this are all in the Canvas shell. But for the time being, let's just launch SQL 2019 Express. It's a bit chunky. It's a bit of a chunkster. So it'll take a little bit of time to download and virtualize. But we'll just let that go. There we go. It says it's running. Okay. But I find that sometimes you have to quick launch twice, and sometimes that works. Sometimes I get 2 instances of it, sometimes I don't. Yes? Oh, yeah, that'll, yeah. I mean, it should auto-launch, but, yeah. Oh look, I do have 2 instances of it. There we go. Yes. We are struggling to connect to the server.
Yeah, I can't lose the service.
Okay, so let me show you how to fix it. Stop the application. Stop. There we go. Stop.
Sir, we tried to stop it, like, I had to reset, like, I turned it on, turn it off.
Like the whole computer?
Yeah. Like, it wouldn't stop.
Are you getting the we are struggling to connect to the server as well?
I had that, I reset, and then it worked this time, so,
You had to reset your whole computer?
yeah.
Alright, well. What an abomination. I don't even have anything funny to say.
You can't even use RF on it.
Well, at least there's the reassurance that once we graduate college, we will definitely have job opportunities in this field. That's the fun.
Fixing busted computers? Yeah. Oh man. Has anybody in the room watched the IT Crowd? It's a somewhat older British comedy about guys who work in an IT department, which consists only of those 2 guys in like a large unspecified company. And it's kind of funny because, well, I mean it's funny because it's a comedy, but there's this one particular episode where one of the guys who works in the IT department is mistaken for a window cleaner because he's sort of, a window cleaner leaves his bike and window cleaning apparatus in his apartment, so he's like trying to find him, so he's riding this window cleaning bike through the city, and he sees some person he went to high school with, and it's like, I'm not a window cleaner! And then it's like, you know, oh, so what do you do for a living? Oh, you know, I'm in IT. So what do you do then? Oh, it's mostly, you know, getting viruses out of Windows machines. So you are a window cleaner then. Yeah. By the way, every password you use should be at least 30 characters. Yep, passwords should be at least 30 characters.
What if the website you're making the password for doesn't let you do 30 characters?
Whatever the max is, that's what you go for. Yes? Your computer's not working? Well, there are lots of other seats in the room. Yeah. Okay, Mohawk apps. Let's see if you can. I know it's early in the morning, Mohawk apps. Come on. Oh. That'll do it. Oh, come on! There we go. Loathing. Hatred. I don't need to know the news. Go away, the news.
Well, we gotta go back to Windows XP.
Now there was an operating system. It came with bloody pinball.
Yes,
That was a good pinball game.
exactly.
Minesweeper came with it. New Windows doesn't even come with Minesweeper. You knew that Windows was like going downhill when like Windows 8 or something. It's like, oh, I want to play Minesweeper. It's like, you need to connect to Xbox. It's like, but it's Minesweeper. There we go. All right. We got the program. Hooray! Yay! So, okie dokie. Artichoke. So, it is important once again to review an important and fundamental distinction between this thing and the database process itself. The first thing that it gives you is connect to server, right? Now, if we were connecting to a remote server, such as we will be doing in server-side programming, we would use this dialog to connect to that remote server and use this database management tool to do that. But as it happens, SQL Express is running locally inside of this machine. This is a local database. It's a database which is exists in the same way that XAMPP runs a web server on your own machine. So, the default values here will work. Just click connect. Just understand that the thing you are connecting to is a separate software process. Make sense? Okie dokie. So, now for another very important thing, how to import files. So, SQL is like SQL code is a sequence of SQL statements. if we take those SQL statements, collect them up into a file, we can have a database engine load all of those SQL statements, read data into a database, create the database, perform operations on the database. It's a little bit like like how Python actually works. You guys know that Python is an interpreted language, so basically when you give it a Python file, it's not like it's, you're not giving it a whole program that it's compiling all at once like Java. What it's doing is it's just running through that file one line at a time and executing the statements in that file, right? SQL is operating in the same way. So if you all navigate to Canvas, my Canvas, there we go. Sixth time to not be able to enter my password. Will he get it? Come on. There we go. You just have to type really deliberately, right? But if I can't get into my account, nobody else can either. Oh, by the way, oh, come on. There we go. 10 bonus points if anybody can tell me what that is and what movie it's from.
What's it does? The Coruscant Library.
Yeah.
The Jedi Library from episode 2?
I think it's episode 2, yeah. Those are the Jedi archives from the Star Wars prequel movies. I thought that was funny. Does anybody know what this one is? This one's a little more obscure. Anybody like Kubrick movies? Hint? Huh? This is the scene in 2001: A Space Odyssey where they shut down HAL 9000, which is the evil supercomputer.
Better than the images my high school had. They just had pictures of nature or something in the course for mathematics.
I mean, there is mathematics in nature, but I don't know, I always like movie references. So, let's see here. So if we go to assignments and we take a look at Lab 0, basically we've all done like 33% of Lab 0, assuming, how many people are, has everybody gotten SQL Server operating?
Yeah.
Okay, good, no? Well,
It's failing to launch.
okay. I'll come around after all of this and I'll help you out. So within this, you have links to download chdb.sql. This is our community hospital database.sql. Let's download that file and take a look at it. Whenever you are given a file, if it's not binary encoded, it is always instructive, to take a look at the contents. So, lots and lots of database stuff, setting things up. These are SQL statements that create tables. Preview of coming attractions. You can see we have quite a few tables. These are statements which insert values into tables. These are the C in CRUD. You can see there are quite a lot of these. You can see this is quite a large file. Most of these are insert statements. So really, all this file is doing is creating a series of tables and populating those tables with a preset set of data. So let's load this up onto the server. File. Open. File. Find the file. Click. It loads the file. Very good. Now we execute. Executing query. And there you have it. Our query has been executed. Congratulations. Do that one more time and you have completed Lab 0. So, if we take a look in our databases, if the thing's not, don't tell me you've crashed. Have you crashed?
Mine says not responding.
I have a question. If we want the files that we saved to people I saved, we go to the users directory, does that keep them saved or no?
For these, you should save these to your network drive if you want anything to be permanent. Ideally, you would have external media that you would plug into these things every day when you come to class. Stop, remove. Try it again. I'm just see here. Connect. Okay, query executed successfully. Now let's execute our own query. New query. There we go. So, let's write a select statement. Select star from, now we just need a name for some table within the database. Using the handy-dandy hierarchy view on the side, we can see that in our CHDB, in tables, we have all of these different tables. Let's take a view of the patients table. Select star from patients. There we go. You probably don't have to save it as a file, but let's just save it as a file. Execute. And there you have a view of the data in that database. Make sense? Has everybody who got this loaded, everybody has got this far? Yeah? Try closing it. Okay. Go to the cloud. Okay. So for everybody who, attention! For everyone who is having this thing fail to work, please go to the cloud paging player, stop the process, remove the process, and try relaunching it. Okay? I'll see if I can increase the magnification on this. There we go, that's better. So, most of the time you're not going to want to view everything in the database all at once, right? You'll want to see more specific information from the database. Along the top of the table here, you'll see that we have labeled columns. These labels are our field names. We can use these within our queries to reference data within a table. So, the star means all. But if we refine that to say, oh, how about I want first underscore name, comma, last underscore name. Execute that. Ha-ha. Now you can see that the data which is returned from the query is only first name and last name. Does that make sense? Question?
How do you get to pop all the information at the bottom? Mine's not popping.
It just kind of did it automatically for me when I clicked execute.
You saved your new query though.
If you go to Window, Show Results pane, that'll do it. Awesome. Question? Still nothing? Try a different computer then, I guess. Alright. Good. So, does this make sense so far? So this is kind of the next step up for select queries. So, let's go into So, it is conventional to capitalize keywords and to place each clause on its own line. If the statements are short enough, this isn't really an issue, but, you know, there you go. SQL statements, similarly to I almost said JavaScript. Similarly to Java statements, are semicolon terminated. That's how you know when the query has ended. So, the distinct keyword may be used to find only those items that are not duplicated. So, if we go back to SQLite, SQL Express, Patience likely doesn't have a lot of duplicated information, but if we select star from nursing units, execute that, we can see well, that's not a whole lot of overlap either. Select distinct beds from nursing units. You can see that in the beds column, there is quite a bit of repetition in that data, in those data. And there you can see, executing select distinct beds from nursing units, it gives you all of the unique values within the given data, right? So this is important. It's not showing you unique records, it's showing you the unique items in the output results. Does that make sense? So far so good? Very good. It's much better to have these demonstrated rather than just staring at slides, I feel. So, sorting. Sorting is very important. I read in a textbook once that 1/3 of all computing power in the world is used sorting data. This may or may not still be true. It might be more true than it used to be. Sorting is a very important, sorting data is a very important thing to do to it. So, order by allows you to specify one of the columns in the table and order the data according to that column. So, for example, select star from provinces. There we go. Let's run that. We've got province ID and province name. Order by, is it order by with a space or no? Order by province name. Oh, is it already in order? Oh, alright, fine. Look, see kids? It's the same data as before. Alright, select star from patients, order by last name. Execute. There you go. And you can see we are, in fact, in ascending order. You can also use the following. Specify it as descending order, and you can see that we are now ordered according to, descending alphabetical order on this field rather than ascending. Make sense? So far so good? Hopefully this isn't like destroying anybody's brain so far. Yeah? Okay. Good. Yes. So, now we come to something that is just a little bit trickier. We are now retrieving a subset of the data rather than the whole table. Up to now, every time we've done a select query, aside from the distinct, labeling something as distinct, every time we've run a query, we've gotten something for every record in the table. Now, we want to be able to filter them. Right? So, the where clause is used to filter your results according to the given condition. The given condition is going to feel very similar to a good old-fashioned if statement. Essentially, you write yourself a Boolean expression. It's evaluated against every record in the table. If it evaluates to true, then that entry is selected to be part of the output. If that condition comes out false, that entry is not selected to be part of the output. This is what it means to be a filter. Does that make sense? Shall we try it out? So, select star from patients where let's see, do we have age here? I guess we'll do height. Where patient height is greater than 160 centimeters. Execute. And there you can see we've got quite a number fewer entries. We can refine that. Let's get everybody over 2 meters. Wait, is this in centimeters? Or is this in inches? Because 2 meters is like quite tall for a person, isn't it? Anyway, doesn't really matter. You can see that refines the list quite substantially. If we refine that even further, I think that 210 might be our theoretical maximum here. Greater than 208, you can see, well, you guys get the idea. Does that make sense? So we're taking the database and we are filtering it for the results we're looking for. In the real world, most of the time when you're pulling information from a database, you will be doing this. You will be using a where clause. Databases can get really big, and not filtering it.
You almost never need all the data at once. So.
Exactly. Now it depends on the table. Like if it's a small little lookup table, like that provinces table that we saw earlier, you know, you might need that in its entirety frequently, sure. But something like this, which, you know, let's be frank, this is the real data, right? There's like 4,000 entries in this table. Do you need all 4,000 entries? Probably not, right? Now, this kind of leads into a discussion about division of labor between programming languages. Hopefully when you folks were in client-side, one of the discussions you had was the division of labor between HTML, CSS, and JavaScript. Everything should do what it's good at, right? So, what is a database good at?
Saving and organizing information.
Saving and organizing information. Yes. The database can perform these types of operations very, very, very quickly. Extremely quickly. Databases have all kinds of really strongly advanced algorithms that have been used to accelerate how they accelerate their performance. Things like B trees, the same sorts of algorithms that are used to control the file system in your computer, right? So databases are really, really good at searching for information, pulling records, recording things. These types of operations. If you are, one of the applications that most of you will see this semester is hooking a PHP script up to a database, right? If what you're doing, if you think you're making your life easier by just doing, select star from table in your PHP script, loading all of that data into your PHP script, and then chugging through that data there, you're doing programming in a manner that is deeply suboptimal, right? PHP is a general purpose programming language, which means that it only searches as efficiently as you do, right? It's only as good as the search algorithm that you encode in it, which means you're probably not going to be able to beat the database, right? So, use the database for what it's good for. Generally speaking, you should try to offload as much responsibility as you can to SQL from places like PHP. Now there's some stuff that PHP has to do, like for example, password hashing, right? But just looking stuff up, that's what SQL is for, right? Your SQL needs to be better than select star from table. Okay? Does that make sense? All good? Very good. All right. Very good, very good. So, similarly to if statements in regular programming languages, you can combine different conditions together using and or operators. In SQL, and or are they are keywords and you put them in as keywords. I believe Python does the same thing, if I recall. Otherwise, these are the and or that you all know and love already. They operate in the same manner. Yes. So, it is important to respect the order in which these clauses occur inside of an SQL query, right? First, you tell it what you're selecting, then what table you're selecting it from, then you provide your filter, then you tell it how you want the results ordered, if you want the results ordered. Make sense?
Does it throw an error if you do it in the wrong order?
Excellent question, let's see. Yep. Incorrect syntax. So that is an honest to goodness syntax error. Yep. Yeah, it's not a programming language, but it does get syntax errors. Here's a question. Can where and order by be exchanged?
I don't think so.
It's given us the little squiggle. Yeah. So there you go. You have to do things in the right order. Alright. So, expressions. One thing that is not well covered in this program is the difference between a statement and an expression. I have a particular soft spot for this, as my doctoral research essentially was on the subject of programming language grammars. So I am what you might consider an expert in the construction of programming languages. So here's the explanation of the difference between a statement and an expression. A statement is anything that ends in a semicolon. There you go. It's a little more complicated than that, of course. If statements, you may notice we call them if statements, may contain other statements. In fact, most of the time they do. So statements may contain other statements. Expressions may contain other expressions. It's a little like the difference between an expression and an equation in normal algebra. Everybody remember algebra? Hopefully everybody remembers algebra. You guys do algebra? So if I were to say 3 plus 7x is equal to 10, and I tell you to solve for x, that is an equation. Why do we call it an equation?
Because it equates two sides.
Yes, it equates two sides using the equation operator. But each of these little things on the side, right? Each of these is an expression, right? So, for example, if, in math class in elementary school, you were given something like, 3 times 4 minus 7 over 2. The text that would appear is simplify the expression, right? Why is this an expression and not an equation? It lacks the equals sign, right? So, within the context of a programming language, and understand, of course, that programming languages were modeled on things like algebra, the equals sign does not equate one thing to another. What does it do?
Assign.
It assigns what to what?
Information to a variable.
Information to a variable. What is a variable?
Memory space that can hold data.
Very good. We are writing information into a spot in memory. That's what the assignment statement does, right? So if I say x is equal to 7 plus 3, this thing is a statement. These things are expressions. Right? Now expressions are interesting because expressions are also contain nested sub-expressions. So not only is 7 plus 3 an expression, but 7 and 3 on their own are also expressions. All literals are expressions. Make sense? You could even think of these things in the form of a tree. A tree is a data structure that you guys will study when you do data structures and algorithms. Right? This is what's known as the abstract syntax tree. This is what your program gets broken down into by the compiler before it's translated into machine code. So, SQL, while it's not a proper programming language, it still contains statements and it still contains expressions. Column names are expressions in SQL. Column names, you can think of them at the same level as a literal, right? They're not quite variables. It's not quite correct to think of them as being variables. You also have literals in the regular sense that you expect from Java. You guys know what I mean when I say literal, right? Okay. Yeah, so a literal is anything that is like, it's literally that in a programming language. Like when I write 3, it's literally 3, right? If I write the string hello, that's literally the string hello, right? Another way to conceptualize a literal is that it is data that does not contain any sub-operations, right? Another way of thinking of it, they are the end nodes of the tree.
It's just what you see is what you get.
What you see is what you get, yes. That's what a literal is. So all literals are possible expressions in SQL. This is actually a statement saying almost nothing. You can perform like mathematical or like concatenation operations on things within SQL statements. So for example, if I say 10 plus 190, that works, right? The expression is parsed, and we get all of the entries which have a height greater than 10 plus 190. Make sense? Okay. That's kind of trivial to do, but yes. Yes?
So is 10 plus 190 a literal, or like would 200 be a literal?
This is an expression. 10 is a literal, 190 is a literal. 200 is actually neither a literal nor an expression. It is the result of a calculation.
But if you just wrote 200, then it'd be
Yes, if you just wrote 200, then that would be a literal. Obviously, there's no reason you would ever do this. This is just for demonstration.
This is actually like fractions of a millisecond less efficient, so you do not want to do this.
Yeah, like this is calling for an unnecessary calculation. However, again, I will often do things that are inefficient for the purpose of teaching. So, like every time I speak. So, in SQL, we also have functions. We have functions available to us. Things like length of a string. Things like square root of a number. Things like the string, convert to a string, the square root of a number. Get date. That's a pretty important one. So yes, in this class we will be talking about how to get dates. I know. Every time I make jokes like that, you'd be surprised how quickly like the YouTube comments fill up with absolute nonsense Russians. They're always Russians. So, conditions. The thing that you put inside of the where clause may also be termed a condition. The purpose is to specify a combination of one or more expressions and logical operations that evaluate to true, false, or mysteriously unknown. This is a list of your comparison operators in SQL. Please note differences between these and, Java particularly. How many equal signs is that? Just the one. How many equal signs would that be in Java? 2. How many in JavaScript?
Well, it depends on strings.
Common misconception about Java and JavaScript. The triple equals in JavaScript is more closely analogous to the double equals in Java than the double equals in JavaScript. Because Java by default does, it even gives you a type error if you try to compare things that aren't compatible. So we have one equal sign here. What operation are we therefore inferring does not exist in SQL? That's right. This is normally used for assignment. Because it's now being used for equality, that means that assignment doesn't exist. Okay, sure, but, okay, question?
Would that not be the purpose of update in CRUD?
Precisely so. The table itself is the memory you're working with, or the set of tables. So you don't really have, at least yet, when we get to stored procedures, this may change, but for the time being, there are no variables. All right? You have the data in the table, and that is what you operate on. Not equals, greater than, less than, greater than equal, not less than equal. In or not in, interesting. Between x and y. So this is it really ticked me off to no end that this is now correct syntax in Python. You can actually say something like that, right? Oh, Python. But yeah, normally this is not an allowable thing to do in a programming language. Between x and y is serving this purpose, checking if something's in a range, right? Now that's a strange one. We'll have to come back to that one. Exists, okay. Also one that we'll have to come back to. Is or is not null. That one hopefully is a little more self-explanatory. You may have noticed as we were going through the patient's table, some of the entries were null. This is simply a test to see if that value is null or not, right? Here are some examples. So, let's say, select star from departments. Let's just see what our data looks like. There are our departments. Where department ID in 1, 2, 3. Did I spell that correctly? 125. There you go, 125. Where department name is in housekeeping or maintenance. However, what mistake have I made?
Those need to be a string. So you
Yeah,
gotta-
those are strings. Those are string literals. And there you go. Housekeeping and maintenance. So the in operator allows you to specify a set of things, and if the thing you're looking for is in that set, it passes the filter. This seems to be a contraction of where department name is equal to housekeeping, and I like to offset, there you go, and department name is equal to, oh, that one should be an or. There you go. That has the exact same effect. Does that make sense? Logical equivalency. Good, good, good. Not in is just the logical conjunction of that, because that's what not does. Yep. So, like is a bit strange. The best way to think about this is fuzzy matching. So, the percent character is a wildcard character. So when you use like, you're saying, I want strings which match this pattern containing wildcard characters. So for example, if you wanted every patient whose name starts with the letter A, whose last name starts with the letter A, select star from patients, enter where last name is like capital A %. Why are you complaining?
Double quotes.
Oh, yeah. That's going to take some getting used to. There you go. And you can see that this is exclusively every patient in the table whose last name starts with the letter A. If you want to refine that search, you could say, okay, how about everybody who starts with AR? There they are. You can include multiple of these, so perhaps all last names containing the letter lowercase k. Luknor, Jekelovich, Fishlock. Fishlock is a good last name, I like that. There you go. Every entry where this column contains a k. Does that make sense? Don't worry, we will get lots and lots of practice writing all of these types of queries. There will be, is that new computer working? All right, so it's just that one then? All right. Should file a ticket. PC 14. All right. Make sense? Very good. And, yeah, okay. So here's an interesting one. Select star from patients where allergies is null. I think it was is null. Yes. All of the people in the patient's database who have no allergies. But here's an interesting thing. Maybe we just need to know how many people do not have allergies in the database. $449 don't have allergies in the database.
And then, like, if you were doing this in a program, you could take that and compare it to the total amount of patients, so you can see what percentage of your patients have an allergy.
Yes. That would be, you know, like you can get that information from the database as well, right? Just count star from patients tells you the total number of entries in the database, right? So as we can see, approximately 10% of our patients do not have any allergies. But, you know, again, you would, like, whatever is sending these queries would probably be the thing to calculate that. Or at the very least, that would use more complicated SQL queries than we yet have covered in the very first week of class. So, sound good? So, this field here is, that expression can be used to post-process your data. So, let's see here. You've got a large number of mathematical functions which are built in, which should look to each of you a little bit like the C Standard Library math functions, which, by the way, are the math functions that everything has because that's part of the kernel. Things like absolute value, arccos, arcsine, arctangent, cosine, cotangent, degrees, exponentiation, floor, ceiling, logarithm, square root, square, tangent, sine, round, sine, random, radians, power, pi, log base 10. All of your math functions are in there. You also have a large number of string functions. Left trim, right trim, Unicode, character index, character, replace, replicate, reverse. All of these are operations that you can perform on strings. They will have analogies to some of the string operations that you used in Java, but some of them will be a bit more specific. You also have date and time functions. I'm not going to demonstrate each of these, obviously, but you have date and time functions that allow you to work with the special time-based data types that we will be seeing later on in the course. Where is it? Oh. There's no actual date time. I was going to say it's date time. This is the function that your parents want to call, right? Get it? What's their name again? These are functions on columns. I've already shown you what count does, but you've also got ones for max, min, sum, and average. Average might be interesting. So hopefully you can see that, like, in SQL, it almost kind of feels a little bit more like speaking, like regular English language than programming languages you've used so far. it's a little bit COBOL-ish, you know? So select average, let me just see the table again. Doop. Select average patient weight from patients where allergies is null or is not null. There you go. And I presume that's in kilograms. That is the average body weight of patients who have allergies in the database. And it's kind of cool to just be able to to write that and have it execute, you know? It's like, you know, any type of thing you want to know about the data in the database, you can use one of these things to pull it out, right?
The average person with an allergy is about half a kilogram heavier than a person without an allergy.
Interesting. Although these data are not based on any real data, that actually is just literally like the effect of random generation on the average. Yes. If you want to do science on these patients, okay, just keep in mind these are fake people with fake made-up numbers. Any inferences you draw from these data do not apply to real humans. Although it's fun to you know, you can imagine like many papers could be written just on doctors could write papers just by doing a couple of SQL queries on patient databases. But there's a lot of legal stuff and rules about why you're not allowed to do that actually.
I mean, I'm sure there are probably studies that do something similar, just with a lot more restrictions and stuff. They're not looking at the raw database.
Yeah. See, the issue is that except in very specific circumstances, you generally require consent from the people who you do science on, even if it's just a matter of looking up their information. When I was at the university, I had this occasion to speak to the body at the university that governs research ethics, and that was the kind of thing that they were concerned with. Basically, the thing I wanted to do was train a model over old student assignments and see if I could draw some inferences and correlations about okay, but what's actually hard in the course? Because if you knew what people, statistically, if you knew what subjects, what subtopics in a course students find hard and you can justify it, then you can use that information to correct the course in a way that addresses those topics better and more, right? You could pull it, you could have analytically derived curriculum, but that's experimenting on humans. Even that is experimenting on humans. So yeah. Anyway, yes. So, that's the end of the slides. Yay! So that's it. I think we basically did Lab 0 well in excess of what Lab 0 is. If you really want to, you may take a moment, download the other file, and upload it into the server. But otherwise, I'll take any questions. Yes?
So most of our labs are just using this database and taking information. Is it quizzes or how are we doing the labs?
The labs will be of various types and things. Obviously, there's more to SQL than just select statements, right? You know, we've done reading, but we still have to do creating, updating, and deleting. We're going to talk about how to set databases up in the first place, how to read database diagrams in order to construct the databases that are derived from them. We're going to learn how to do triggers and stored procedures and other stuff that's a bit more specific to this particular database software. To be honest, I haven't looked through all the labs yet. I was told by some veteran faculty members that third semester is a heavy semester, and this is not meant to be the heavy course in the heavy semester. This is supposed to be a little bit lighter fare. So, yeah, we'll see if that's still true when I'm done with my updates to it. But fortunately, you guys have the old version before I have a chance to make this course terrible. So, yes. But, like, in all honesty, I probably, like, wouldn't change much of like the slide content, except maybe to reorganize it a little bit. Microsoft SQL Server Express has got to go. It should be replaced with Docker, which means that you guys would be doing stuff in like a VM, right? But this is all like essential job skills anyways. Some people, actually most of you I had in the winter, so you know what? Right at the end of last semester, the Stack Overflow developer survey, the results from that went live. You want to see? This is like current data. It's lovely. Stack Overflow developer survey. Boop. All right. So, technology. Most popular programming languages. Oof. JavaScript. Not a programming language, not a programming language. Python. Bash/shell is in 5th place. You know how I keep saying you should learn Linux? Anybody know what TypeScript is?
Vaguely.
What is it? Yes. So TypeScript actually compiles to JavaScript. It's like JavaScript, but you've put like a decent type system in it, and that's TypeScript because JavaScript is awful. Java, C#, C++, etc., etc. Databases. PostgreSQL, MySQL, SQLite, and Microsoft SQL Server. So it's like at 30%, but like, come on, this is the one we should be doing.
Where is Rust on the programming languages?
Ooh, I've got a Rustation in the crowd. Let's see here. Right there, right under Go, 14.8%. Rust has been making gains. It's in like, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Not bad.
My friend's dad programs in Rust, so.
Like it's increasingly the thing. I've been hearing more and more people are like actually using it for industry stuff.
Yeah.
If you want to learn Rust, man, I highly encourage that. But just be warned that Rust is a difficult language. I think it's just having seen a little bit of it. I think it's a little more difficult than C++. And C++ is a difficult language. But my career advice to everybody is learn difficult languages. Pick up skills that other people have difficulty with, right? You've got to learn rare skills because rare skills are employable skills, right? Particularly when you've got an up-and-comer. Rust is still, like, Rust is an up and comer. It's like my dream that I'm given like a 5th or 6th semester course and I can just teach Rust. That's like my dream. But there's something I wanted to show you guys. If you can't read that, that top one says Docker. Docker. 71.1%. So if you don't know what Docker is, you kind of first have to know what a virtual machine is. So Docker runs containers. Containers are miniaturized virtual machines. Your typical virtual machine, which is like a full-blown operating system instance, those things, like, you're kind of lucky to squeeze them in under 5 gigabytes, right? But your average Linux container is nominally under 200 megabytes, right? So you can see why people like these containers. You can spin up like 10 or 20 individual little operating systems that are all only running one program, right? The whole, like, the idea behind a Docker container is, listen, I'll configure it, I'll give it to you, and you can run it. So you don't have to configure it, right? The thing travels with all of the configuration that it already needs, which is like, you know, like, configuring things is a huge pain in the ass, as I'm sure anybody who's ever tried to use Linux will attest. So, yeah, Docker. It's basically it's my mission to try to get as much of the program into Docker as possible, because like that's a job skill right there. Anybody know what NPM is?
Node package manager?
That's the Node Package Manager. That's right. Anybody know what pip is?
Isn't that like Python?
That's the Python Package Manager. Yeah. Anybody know what Kubernetes is? It's basically an add-on pack for Docker that allows you to organize containers. So that is the current state of the industry, my friends. However, if you're like, oh man, I should really learn Docker, yes, but wait until you're finished server side. Because until you have like server containers and database containers, and like until you have something to do with it, you don't really have a reason to use it, if that makes sense, right? So like, learn stuff and then get into Docker. Okay? Sound good? Alright. Everybody finished with me talking? Alright, thank you very much everybody for your time and attention. We'll see you next week. For homework, go hug a kitten. That's good homework.
I have 2 cats.
2 cats with no kittens? Ah, well, you gotta get some kittens in your life.
One of them's quite the opposite. He's a very old man.